Hello students, we are going to study chemistry chapter classification of elements. We are going to study modern periodic table part 2 in this video. In the previous video we have studied Mendeleev's periodic table and we understood that there are drawbacks in Mendeleev's periodic table. In modern periodic table, these drawbacks or the problems present in Mendeleev's periodic table have been solved. Okay, and in what way these problems are solved we can see here. We'll study them as advantages of modern periodic table. Okay, so the first point is the wrong position of some elements like argon and potassium, cobalt and nickel have been solved. Argon and potassium, here is argon and here is potassium. The position of these two elements were anomalous, means these two elements were not following the rule of modern periodic table, following the rule of actually Mendeleev's periodic table when they were kept on the basis of atomic weight. Okay, argon had higher atomic weight and potassium had lower atomic weight. But when these elements were kept on the basis of atomic number, this anomalous pair of elements was solved. Okay, argon has 18 atomic number and potassium has 19 atomic number. Now this problem has been solved because these two elements are in increasing order of atomic number. When the elements were kept in increasing order of atomic number, argon and potassium, there was no problem with the position of argon and potassium. Okay, because these two are in increasing order of atomic number. In the same way, cobalt and nickel. Now, if you look at the atomic number of these two elements, then there is no problem. So 27 cobalt is in front of 28 nickel. Okay, higher atomic number is at the back and lower atomic number is in front. So this is solved. Okay, but when these two elements were kept on the basis of atomic weight, there was a problem. Okay, so higher atomic weight cobalt was in front, whereas lower atomic weight nickel was at the back. Okay, so this is the solving of anomalous pair of elements in the modern periodic table. Now number 2 is isotopes. So isotopes are the species of the elements which have different atomic weights but same atomic number. Okay, when elements were kept in increasing order of atomic number, when atomic number was taken, then one element needed only one position. Okay, so there were no need of an element having two positions, right? When the table was made on the basis of atomic weight, element like chlorine required two positions. Okay, because it has two atomic weights. Okay, according to isotope. But when it was kept on the basis of atomic number, these two positions were not required. That is why position isotope is solved in this table. Chlorine required only one position, which is this, atomic number 17. So position of isotopes were solved. And number 3 point, the position of hydrogen. Hydrogen can be kept in group 1A as well as in 7A. It is because hydrogen can gain one electron just like lithium, sodium, potassium, and can become H plus in the chemical reaction just like Na plus, K plus. Okay, so because of this reason hydrogen is kept in group 1A, and at the same time hydrogen can be kept in group 7A because it can become H minus by gaining one electron just like chlorine. Chlorine also becomes H minus. Okay, so you see, because property hydrogen can be kept in group 7 as well as group 1A, right? But hydrogen is kept in the beginning of the periodic table. It is because it has the least atomic number, that is 1. Okay, so because of atomic number 1, hydrogen's place in this table is justified. Okay, because it has beginning number 1, that is why it is kept at the top of group 1A. So this way position of hydrogen has been justified to some extent, right? So it can be kept in group 1A, it's one electron just like lithium, sodium, potassium, and hydrogen can be kept in group 7A because it behaves just like group 7 element fluorine, fluorine, bromine, iodine, because it gains one electron, okay, to become H minus just like chlorine, fluorine, bromine, iodine. So this problem is solved to some extent. Now next is the elements are divided into subgroup A and B. When the elements were divided into subgroup A and B, it was easier to separate the elements which had different chemical properties. Okay, so lithium, sodium, potassium has been separated from copper, silver, gold. Copper, silver, gold and lithium, sodium, potassium were kept together in Mendeleev's periodic table because there were no subgroups A and B. Okay, this middle part of elements are subgroup B. These are all subgroup B. Okay, and subgroup A elements are, this is subgroup A elements, and this entire part subgroup A elements. Right? So when elements were divided into subgroup A and B, the elements having different chemical properties could be separated. Okay, so this way lithium, sodium, potassium has been separated from copper, silver and gold. Okay, this is 1B. Number 11 is 1B. Lithium, sodium, potassium are in 1A. Group 1A, group 1B. These are separated. Okay. Now next is it separates metals from non-metals. You see metals are in the left side of the table from 12th number left side. These are all metals. Okay, and non-metals are here on the right side of the table. Metals and non-metals. Okay, so in this table that is why the elements could be recognized and these could be studied separately easily. Okay, whereas this this advantage was not there in Mendeleev's periodic table. Metals and non-metals, okay, they did not have separate positions. Representative and transition elements have been separated in the modern periodic table. Representative elements are group A elements. Group A elements are representative elements. Whereas group B elements are transitions. So in modern periodic table, representative and transition elements have been separated. Representative elements are normal elements. These elements follow rules and regulations of modern periodic table, whereas transition elements are elements with specific properties, special properties. We are going to study about them later. Okay, so in the table, representative and transition elements have been separated. This made the study of elements easier. Okay, normal elements and transition elements. Now next is group 8B, iron, cobalt, nickel. This is group 8. Group 8 is kept in subgroup B in 3 different columns. Okay, iron, cobalt, nickel, iron, cobalt, nickel. So these are kept in subgroup B so that they are treated as the elements with special properties. Okay, these do not break the format of periodic table. Right? Any disturbance of periodic table, there is no disturbance in the periodic table. So group 8 elements are kept in subgroup B in 3 different columns. Iron, cobalt, in 3 different columns. That is why the study of iron, cobalt, nickel is easier without any difficulty in this table. So these are the advantages of modern periodic table. Now okay, let's see what are the advantages. Number 1 advantage is anomalous pair of elements have been solved. Okay, when elements were kept in on the basis of atomic number, the problems due to atomic weights were solved. Number 2, isotopes needed only one position. Okay, because the table was made on the basis of atomic number. That is why there was no problem regarding isotopes. Number 3 point, position of hydrogen. Position of hydrogen was solved because hydrogen has the least atomic number, number 1. Next position is next point is subgroup A and B. Elements are divided into subgroup A and B, and this could help in separating elements which had different chemical properties. Okay, elements having different chemical properties could be separated in subgroup A and B. Okay, next is it separates metals from non-metals. All metals are in left side and non-metals are in right side. Okay, so metals and non-metals studied easily. Okay, next is representative and transition elements. Representative and transition elements are separated here. Representative elements are group A elements. All group A elements are representative elements, whereas group B, subgroup B elements are transition elements. So transition elements have special properties in them. Okay, so we'll study about them later, whereas representative elements are the normal elements. They all follow the rules given by periodic table in a simple way. Okay, now group 8 elements have been kept in subgroup B. Okay, group 8 has 3 different columns where iron, cobalt, nickel groups of elements are kept separately. Okay, so that is why there is no complication, there is no problem in studying group 8 elements in subgroup B. So these are the advantages of modern periodic table, and in the next video we are going to study about groups and periods of modern periodic table.